you some feedback on the slides. Okay, so I mean, you obviously get this information also in the teams, right? Because well, not many of you have left today. So how we proceed from now? First of all, so you, the groups that have presented, I will ask you to submit your slides. That's kind of obligatory part. To teams, there will be an assignment for that. And well, if you can and if you want, also some other artifacts that you have, like for instance, the 9 workflows, the process models that you used for the presentations, you can submit them right now already if you want. Then for the final report, right, that is due in like 2 to 3 weeks. Well, there, I mean, I'll write you a bit more about, well, the structure that is expected, but basically, well, the findings that you have, put in a nice document with descriptions, with screenshots, and so on. And then I will also require you for the final group report to submit basically all the artifacts that you have, including, well, the report itself, right, the document, your workflows, be it the code or the 9 workflow, the process models that you generated along the way, simulation scenarios, tables, so basically all the artifacts that you have created, I will ask you to upload all of them. So, yeah, with that, I mean, we can conclude with the, let's say, official part of the lecture. So, well, especially for those of you who stayed until the very end, thank you very much for participating in this course. I hope that you enjoyed and could learn a lot, despite it being very, very dense and complicated class. So, well, I wish you all the best for your further studies and your careers. Thank you very much for being here, and well, see you around. Okay, now to your comments. So, I mean, I won't scream out loud anymore, right? Because there's not that much audience interested. So basically, so regarding the last thing, what you have done here is not object-centric. It is declarative. So
sorry.
please change it.
Okay.
So in the text, so it's declarative process mining that you have done. Regarding the simulation, I was a bit unsure. So basically, you said, okay, you had like 5 samples with perfect fitness, but what did you? Or sorry, for performance checking. Let's talk about simulation first, okay? So for simulation, which model were you using and what kind of simulation scenario was that? Because basically what you showed during the presentation was, okay, look, there is a simulation tool, I can tweak things there. But like, this is what I showed you in the lectures. What was expected from you is to kind of apply simulations to get some new insights or results. Right?
Okay.
So what did you do for the simulation scenario?
For the simulation scenario, we use this
Okay.
to simulate.
Okay.
Yeah.
Yeah.
And we already say that we run this on Python to get this. So after that, we run it on the simulation to
Yeah,
get
okay.
the result. Okay.
Okay, so basically for the simulation, like we'll get back to discovery in a second, but basically for the simulations, you may really want to first simplify the model by all means necessary. We'll talk about it in a second, so that your simulation is kind of then understandable and realistic, right? So because in this model, I mean, okay, you can run the simulation, but also you cannot really interpret much the output because the model is so complex, right? So we'll first talk about simplification of the model, and then, so with the simulation, basically what the simulation is for is that it allows you to answer some questions about the process, primarily the what-if analysis. Meaning, okay, you have some assumptions about how the process runs, right? Maybe you can make these assumptions based on the data, right? You can do some performance analysis in your code, and then you can use these numbers, right, and say, okay, well, I put these numbers now in the simulation, I create kind of the baseline model, and now you start kind of experimenting, right? You say, okay, well, this is what the process is right now, but what if I add, let's say, one more manager to work on this? Will it be much faster? Or what if I automate this activity so that now, well, let's say in your data, some activity is taking half an hour on average, and you say, okay, what if I automate this activity so that it only takes 3 minutes, right? How does it influence the process? So these are the things that you're doing with the simulation. And well, since you're generating the MXML logs in the simulations, right, you can then take your logs, put them back into the tool and run some new analysis based on this. So now to conformance checking. So conformance checking, right, you have two inputs, namely the event log and the model.
Yes.
So first of all, which model did you use for conformance checking?
From the process discovery model.
Okay. Okay, that makes sense. And which samples? What were the samples? Were they just some random samples or? Okay, nice. So, I mean, it makes then sense that you arrived at 100% fitness, but also, well, you have perfect fitness at the cost of a very complex model, right? That is
Yes,
unreadable.
yeah.
Maybe what you could do, at least for the beginning, the first thing you could do, since you also created your models yourself, also based on the descriptions, right? What you can do is, well, first, you can run conformance checking against those models. So, because those models, right, that are in the descriptions, you can treat them as the normative models, right? Because this is how the process is supposed to run, right? And then you take your logs and you say, okay, this is how the process is supposed to run, and you compare it with how it really ran, right? So this is where you can discover interesting bits, right? So this is what you can do with conformance checking. That's the first thing. And the second thing, when you simplify the discovered model, we'll get to it in a second, you can also then run your conformance checking against your simplified model, right? Because then you'll basically say, okay, we have this model, it has perfect fitness, but it is huge and unreadable, but we can reduce the model size, right? And make it understandable by sacrificing a bit of fitness, basically. So that's how you proceed there. Regarding the the discovered model. And when you discover the model again, well, you have the model discovered, then you'll simplify it, and then what you can also do, right, is you can do some something we kind of mentioned in the slides. This visual assisted analysis. Basically, you can say, okay, well, this is the model of how it runs according to the process, right? This is our simplified discovered model. This is the model that we have created based on the description. You can also visually compare them and say, well, the description says it should be like this.
Yes.
The real model said, well, is somewhat different, right? You can
Yes.
make this comparison.
Yes.
And now, so to the final point, right? So simplifying this discovered model. So basically, I mean, okay, the model is huge. What you can do here are various things. The first thing that you can do is, you filter the event log because you see here, okay, you have, for instance, the 5 most frequent variants, right? What you can do is, you can take these 5 most frequent variants, right? You can, and they together will account for about 100-something thousand traces, right?
Yes.
So you can take this and you can then discover a process model only for these popular variants. And then the process model will be very simple, right?
Yes.
And you can, make meaningful simulations with it and everything, but then you can run conformance checking against this model, right, and full log, and you will see, okay, you have a fitness of whatever, 70-something%, for instance, right? And you can then argue, okay, the fitness is kind of lower, but the model is understandable,
Yes.
and you can then, if you want, even find the optimal part here. You'll say, okay, what if I add the sixth variant to the model? It will get a bit more complex. You will get a bit higher fitness.
Yes.
If you add the 7th variant, it's more complex, but also better fitness. And so with these experimentations, you can then find kind of the optimal spot where you say, okay, the complexity is a bit complex, but not too much, right? And at the same time, the model is has a good fitness, right? So this is how you find this kind of optimal point. And this is something you won't do kind of automatically. This is something you do manually.
Yes.
Also, what I liked a lot, and I even wrote it down to myself, if I only Okay, I didn't note it down, but there was something I liked very much. I mean, a lot of things, obviously, but yeah, okay, I don't have it anymore. And you had a very interesting analysis on the last slide, on the
Yes.
yeah, but I missed a bit where this analysis comes from, because these are the real interesting bits, right? Where you say, okay, yeah, like these things,
So we run it on Python.
yeah.
Yeah.
So, but yeah, well, what do we have here? Okay, 50,000 times